The physical analysis of green coffee can be broken down into four basic categories: size, density, water content, and defect count. Each of these metrics can have a bearing on any coffee's sensory quality and trade value. As such, it's worth the time of any roaster, coffee buyer, importer, exporter, processor, and farmer to have at least a cursory understanding of these important measurements, how they can be obtained, what their causes and effects might be, and to what degree they might be improved upon. Over the next few pages, we'll seek to cover both introductions to broad concepts and to dive deeply into misunderstood corners and clarify complex concepts in order to demystify the physical analysis of green coffee. The Crown is located at 2523 Broadway in Oakland, California. We're a lab and tasting room, as well as an event space and education center. You can read more about us online. Royal Coffee is the parent company of the Crown, family-owned and operated importer in business since 1978 in the Bay Area. And you are on our website right now. Hey folks, this is Chris Kornman, Lab and Education Manager at the Crown, and welcome to the physical analysis of green coffee. This chapter will cover moisture content and water activity. Much like the human body, a freshly harvested coffee cherry is mostly water. A great deal of time and energy are expended to dry the seed of that cherry. Today's class will cover a number of different topics related to water activity and moisture content. We'll look at how drying coffee at origin happens and why it's important. We'll look at moisture content and its implications for roasters. We'll also examine water activity, define terms, and figure out how it differentiates from moisture content. Further, we'll look at water activity and its impact from the drying processes at origin, and then examine water activity and the roaster, topics including safety, shelf stability, and sugar browning. And finally, we'll look at inventory decisions and roasting decisions that can be used based on water activity of green coffee. So what is moisture content when we talk about green coffee? Well, it's simply the percent of the coffee bean which is water by weight. Export-ready coffee traditionally has been defined as 9 to 12% moisture content. Measuring moisture content for coffee isn't terribly difficult. The industry has a number of meters that are available for different price ranges. The Sinar Bean Pro would be the industry standard. It also measures density fairly accurately. It's one that I highly recommend. We use it at the Crown regularly. Other top-loading meters that are less expensive include the Ket and the Shore. In my experience, have not been as reliable as the Sinar, but they are significantly cheaper. There are a number of screw-top meters and probe-style meters that are available also that are in varying degrees of expense, and I have found that those are not terribly accurate in my experience. There's a lot of potential for operator error in those particular devices. In any measurement device, you're going to need to be precise and consistent with your measuring practices. And maintain calibration and verification through standards. The standards and the software in these types of devices tend to be based on a number of programs, and they're related to the most accurate and sort of original method of measuring moisture, which would be to dry the coffee out in a very low temperature oven over a long period of time. Since most folks don't have the time to do that or the resources at hand, these provide a much more accurate and accessible and immediate way of measuring the moisture content of coffee. The way in which they do this is via a method called impedance. In ovens, the measurement is very accurate, but it does take a really long time, and of course you ruin your sample afterwards. And so in the interest of preserving the coffee sample and also having an instant reading, the electrical impedance measurements have taken over as sort of the industry standard. And the way that this works is they essentially measure the interference of a very weak electrical signal that passes through the sample, and then that reading is then interpolated to conform with standards that were based on oven measurements. The post-harvest process of drying coffee is perhaps the most critical time period in terms of quality preservation. Well-documented research from many sources, Dr. Flavio Borem of the University of Lavras in Brazil being a leading voice in this regard, indicates that lower temperatures and longer drying times tend to be beneficial for the longevity of shelf life of green coffee, as well as for its valued flavor characteristics in the cup. Moisture loss after post-harvest drying tied to potassium leaching from the green coffee bean illustrates an important point. And that is that compounds immediately related to coffee's sensory quality bound up inside the green coffee are susceptible to evaporation. This susceptibility is exacerbated by any number of poor drying conditions, improper handling, excessively wet or dry storage, and ultimately by any great length of time after harvest. The moisture content of a coffee bean will not remain stable forever, and it drives home the fact that coffee is an agricultural product with a finite, best consumed by shelf date. The slide shows a number of moisture content benchmarks that I've collected over a number of years. Many hundreds of coffees have been measured and a lot of data gathered. This is the benchmark that we use for Crown Jewel language on the Royal Coffee website, for example. And you can see a bit of a bell curve here as it regards to the moisture content of green coffee. So that 10.5 to 11.2 range is what I would consider to be kind of like ideal or about average. And then the range sort of extends from there. Anything over 12% would definitely be above average, and that sort of 9% or below being well below average. As a roaster, moisture content is immediately relevant to roasted weight loss. All roasters must contend with a loss of product when converting from green to brown. And roasted weight loss can loosely be calculated as the green coffee's moisture content, all of which is roasted away, plus the degree, that would be like time and temperature of the roast. So you add these two together, the moisture content plus your roast degree. And so using roast loss as a measurement for roast degree might be an incomplete picture. For example, 12% moisture content Colombia and a 9% moisture Ethiopia roasted to the same time and temperature under otherwise identical conditions will yield dramatically different roast weights. So if the roast in question is especially light, perhaps like a sample roast, the roast yield percentage for the Colombia might be about 85 grams out of 100, losing that 12% plus a little bit, right? Whereas the Ethiopia would yield roughly 3 grams more roasted weight because of its lower moisture percentage. That Ethiopia might end up around 88 grams out of 100 at the end of the roast. Thus, moisture content can be tied directly to profit and loss for a roaster, much the same as density. Lower moisture content coffees are of greater value in a purely financial sense to a roaster because they lose less weight during the roasting process. Additionally, the presence of moisture in coffee aids the Maillard reaction that's responsible for turning those green beans brown in the process and presence of heat. And so moisture content will also impact the rate of drying in the roaster before color change. More moisture to drive off in the early stages of a roast will usually take more time, and therefore wetter coffees may respond more favorably to longer roasting times as a general rule. Switching gears to water activity, let's talk a little bit about the definition of what exactly this measurement is. Water in coffee is more complicated than a simple percentage. The so-called activity of that water also creates a degree of nuance worth paying attention to, as this measurement can affect everything from product safety to shelf life and sensory quality. Water activity is essentially the measure of how aggressively the unbound water in coffee is trying to evaporate. It's the measurement of water vapor pressure. To explore it mathematically, water activity of a substance like coffee is compared to the rate of evaporation of pure water at room temperature at zero elevation. Thus, the water activity of coffee is always a fraction, or sometimes expressed as a percentage. We might say that a particular coffee has a water activity, often written AW, of 0.5, meaning that its moisture is evaporating at roughly 50% the rate of pure water at room temperature. So how does one go about measuring water activity? Well, it's a little bit more complicated than moisture content, but it does require a device. At the Crown, I use the Rotronic, which you see here. We also have a water activity handheld. It's called a Pocket that used to be produced by Decagon, which is now known as Meter Group. Both of these are capacitance sensors. And in these sensors, which are also occasionally referred to as hygrometers, they consist of two charged plates that are separated by a membrane. As the membrane absorbs water, its ability to hold a charge increases, and the resulting capacitance change is approximately proportional to water activity, as long as that is calibrated against a known saturated salt standard. Right, so the importance of keeping these devices calibrated and in line with their reference samples is really important. The other method of measurement is also known as a chilled mirror, and basically what happens is air is passed over this chilled surface, and then the temperature is gradually reduced. And the temperature at which the water vapor begins to condense on the surface is the dew point temperature, which is directly related to the vapor pressure of the air. This is a longer and more complicated process, and the devices that are used to measure it tend to be very, very expensive. And so it's not very common to see this in smaller laboratory settings. The Rotronic device you see here runs a couple of $1,000s, as does the entry-level one from Decagon. And that's, generally speaking, sort of where these products begin in terms of price point. Just like with moisture content, water activity is essentially set in the field post-harvest processing. Slow, steady drying times at stable low temperatures provide better environment for stabilizing coffee's moisture than do large fluctuations or high temperature conditions. If you consider a raised bed where the parchment coffee is drying, good airflow both above and below the pile, thin layers, and hopefully frequently sifted beans provide a relatively good drying environment. These thin layers on a patio with consistent raking might achieve similar results. And then if we contrast that with a large pile on a patio that does not turn regularly, the center of the pile will not dry at the same rate as the edges, making for problematic conditions. The higher moisture of the interior will constantly try to migrate to areas of lower concentration, which causes high water activity. If we compare both of these different examples with the mechanical dryer, mechanical dryers, if carefully maintained, low temperature settings, constant tumbling, might provide one of the best possible scenarios for coffee drying. However, inconsistent fuel sources, overloaded drums, and the temptation to turn up the temperature to reduce the drying time can result in unstable high water activity levels, and even in a coffee that might achieve the ideal moisture content percentage of 9 to 12% might have too high of a water activity when dried under these conditions. And the consequence of that is that it reduces the coffee's shelf life, quality, and perhaps even causing potential health risks. Just like with moisture content, water activity, I've begun to denote a number of benchmarks across many coffees over a long period of time. And so this bell curve below will show you where I'd consider average and above and below. That 0.55 to 0.57 range is kind of like the sweet spot in the heart of a coffee's average landed. This would be like a rival at a lab for a roaster or an importer, perhaps. And I would consider that range to be not only shelf stable, but also safe for consumption. Anything above that 0.64 range is what I'd consider well above average, and we'll get into a little bit more of the implications of that in the next couple of slides. And then any coffees below 0.45 I'd consider well below average. In my personal opinion, it's far better to have lower water activity than it is to have high water activity, because it indicates better shelf stability. So let's now consider what the implications of water activity might be for roasters. And I like to think of these as being able to be broken down into three essential categories. The three S's of water activity for the roaster. The first would be safety, the second would be shelf stability, and the third would be sugar browning. Water activity has been an accepted standard for indicating food safety since the middle of the 20th century. William James Scott was able to convincingly prove that water activity measurements can predict microbial growth in 1953. And since that time, the measurement of water activity has replaced the measurement of moisture content in most food products as the primary indicator of potential problems with things like mold, fungi, and bacteria. Established levels for these microbes are pretty firm, below a water activity range of 0.6, no microbial proliferation occurs, and foods are generally considered to be free from potential for new contamination. Relative safety can be assured up to about the level of 0.69, and thus the SCA has posted that a coffee may no longer be considered specialty if its water activity level is at 0.7 or above. Of particular interest to coffee folks are the mold types that might contain what are known as mycotoxins or ochratoxins, and these are known hazards to health. A number of profiteering entrepreneurs have turned this into, a possibility of some fear marketing, essentially, buy your coffee from us or else you might be getting danger beans. But the truth is that mycotoxins and ochratoxins are produced by fungi at levels above 0.78 water activity. And the amount of time that coffee spends under these conditions is relatively brief. That's not to say that it's not possible, but it is under good practice conditions of processing and drying, it should not be a problem. And there are a number of other studies that I can point you to that indicate that coffee is not a primary cause of this concern for anyone. There's a 3-part series on the Royal Coffee blog that's easy to search for. You just type in mycotoxins or ochratoxins. So it would be my suggestion that for the coffee roaster, a 0.7 upper limit should probably be the hard stop for most quality control programs. That's where we start risking new microbial activity, like mold growth, essentially. Below that number, the next quality of concern falls roughly between the range of 0.6 and 0.69. And while I wouldn't consider that to be dangerous to health, coffee measuring at these relatively high water activity levels are susceptible to the loss of quality related to moisture migration and lipid oxidization. So related to that potential for moisture loss, at the cupping table, flavors of paper and cardboard frequently signal that a coffee is past its prime. Quality agents sometimes still refer to these flavors as baggy. This, I think, is a misnomer. The coffee certainly, the flavor can resemble that of the jute bags in which the coffee is sorted and shipped, and even coffees that are not kept in jute can end up tasting baggy. And so I would suggest that other terms for this flavor that might be more accurate might include faded or aged or past crop. For most purposes, the upper limit of 0.6 water activity seems like a convenient soft limit for predicting shelf stability of a new coffee. This would help predict stability for, I would say, more than 6 months of post-harvest under normal storage conditions, which might include moderate temperatures, low relative humidity. Best practices might include some sort of a grain pro or other preservation method. These things all definitely help to prevent moisture migration. That 0.60 number is for a new coffee arriving. As coffee ages and as moisture migrates, that number will reduce over time in many cases. And so you can still have a coffee that tastes faded or papery at a number under that 0.6 level, but that 0.6 might be like an early indicator that you have a higher potential for quality loss, in my opinion. As a coffee buyer or inventory manager, you can use water activity to help your decision making from a quality preservation perspective. If a coffee is shipping from a country of origin and the same sample prior to shipping measures with a high water activity, the buyer may wish to pay for additional drying time or for expedited shipping, or select a different coffee with a more stable reading. Once a coffee arrives at its final destination, prioritizing coffees with higher water activities for roasting and usage can ensure that this user is vacating the inventory before the flavors begin to fade. As a coffee roaster, that 0.7 upper limit should probably be a hard stop again for your quality control programs, but it's that 0.6 to 0.69 range that's not dangerous to health but might indicate potential for quality loss. So the implications of water activity and roasting and quality are like I think what most people are really interested in hearing about, but they're also like probably the most difficult to pin down. You know, in terms of the qualitative changes related to coffee roasting and sensory data, as those data relate to water activity, these inferences and assumptions that we can make are anything but firm. Available studies make note of the increased rate or likelihood of browning reactions, such as Maillard stage drain roasting, in correlation with water activity as it approaches roughly 0.70, which is to say that in coffee, higher water activity levels, while increasing the risk of new microbial growth or reduced shelf life as green, might also have some interesting potential in the roaster. Small-scale, non-conclusive trials my colleagues and myself have performed at the Crown indicate a couple of broad-stroke generalities that we can apply as it comes to water activity and roasting. The first might be that coffees of higher water activity tend to respond more slowly during early stages of roasting, reaching lower turnaround temperatures, but then they might progress more quickly between visible color change to first crack than those of lower water activity. Coffees of higher water activity might also crack at hotter temperatures than their lower water activity counterparts. I've also seen less stability or less predictability, I should say, in the higher water activity first crack temperatures, even on the same coffee, whereas lower water activity seems to have a more defined first crack temperature start. Higher water activities tend to have more sensitive reaction to time or temperature as it pertains to final color of the roast. You can actually see the graph of this here. It's essentially it's the same coffee that was dried differently, allowing one to reach a lower water activity than the other. And what we see here is the color track score, the color of the roast, at 3 different roast lengths, and for the low water activity sample, the color changed relatively little, whereas in the high water activity sample, the color change was much more dramatic. High water activity coffees also seem to have perceived sensory acidic quality that might be more persistent in the cup regardless of changes in roast time or temperature compared to perhaps a more ephemeral acidity of lower water activity coffees. So if the coffee already has a bright acidity, it might be less sensitive to roast length and roast color. You can still get that acidity to shine in the cup if it's a higher water activity coffee. So the question of what to do as a roaster ends up largely being in your hands. There's a number of complicated decisions that have to be balanced. Choosing coffees with higher water activities might provide you with some exciting flavors, but also more volatile shelf lives. Lower water activity coffees are definitely going to have a better chance of preserving their inherent flavors over the journey from port to port or at any length of time in storage. Roasting coffees with higher water activity may not need as much heat during the Maillard reaction to achieve balanced flavor profiles, but they might also need longer drying times earlier in the roast. Ultimately, even if we are able to solidify these initial results with further research, there's no substitute for tasting your roasts. Knowledge of moisture content and water activity allows roasters to make informed choices, but it's never going to replace your own sensory observation and roasting decisions. That's the conclusion of moisture content and water activity in green coffee. There are 3 other parts to this series. Physical analysis of green coffee pertains to screen size, density, and lastly, physical defects. So be sure to keep a lookout for those other sessions if you want to continue your learning opportunities. You can, of course, always visit royalcoffee.com and check additional resources there, whether it's Crown Jewels or information on the Crown itself or our blog for further information and educational materials. And you can always come visit us at 2523 Broadway or email us at info@royalcoffee.com or dial the number below to get in touch. Look forward to hearing from you, and thanks for listening.